Hello, this video is the continuation of previous two videos about the reactions of alkene. In previous videos, we discussed about the reactions of alkene with hydrogen halide. Okay. In previous video, we discussed about reaction with hydrogen halide HX, in which we talk about addition of HCl, HBr, or HI. This is what we discuss. Now, in the addition reaction, hydrogen halide molecule serves as the nucleophile, hydrogen ion as the nucleophile, and hydrogen as the electrophile, and halogen as the nucleophile, HX, right? So this is electrophile and the nucleophile. Now, what are the other possible combination, right? X is nucleophile. What are the other possible combination on this addition reaction? So that is what we are trying to discuss. So in this, to look for the other combination, one great molecule would be to discuss is to discuss about the addition of, this is number two, this is about the addition of water. Water, which is H2O. In this, if we look very closely to the water molecule HOH, you can kind of have an idea that hydrogen can act as the electrophile, the OH can act as the nucleophile, H and OH. So across the double bond, hydrogen would be added to one carbon and OH would be added to other carbon. But however, for this kind of addition, so if you take the alkene and we react with water molecule H2O or HOH, in fact, there is no reaction takes place. This addition reaction cannot occur. Now the question is why this reaction is unsuccessful as such. There are two reasons that we can explain for this reaction not occurring. One is the acidity of water molecule. Water, if you closely look at the pKa value of water, it is 15.7. That means this water is very weak acid. The hydrogen in water molecule is very weakly acidic. Therefore, it is not strong enough to use as H plus, or as the electrode, not strong enough electrophile to react with the double bond. That's one explanation. The second explanation could be when this double bond, if this double bond picks the hydrogen from OH, so OH will have to leave as the leaving group. OH will have to leave as a leaving group, but as we know that OH is a very bad leaving group. OH minus, a bad leaving group, or you can say poor leaving group, bad leaving group or poor leaving group. That is why OH cannot leave as the OH minus. Because of these two reasons, water is not a good combination of electrophile nucleophile to add across the double bond. But however, if we need to add water across the double bond, we can do this by using a little bit of water we can add in presence of little bit of acid catalyst. That is why this reaction is called acid catalyzed addition of water. Addition of water. So in absence of this acid catalyzed, the reaction does not occur. But if we use acid catalyzed, then normally we use dilute sulfuric acid as the catalyst there, then addition reaction takes place. And addition will follow the Markovnikov rule. That means hydrogen will add to the carbon with larger number of hydrogen, and OH will add to the carbon containing less number of hydrogen. So you will the product will be the alcohol from the, and that will be the Markovnikov's product. Okay, so only the reaction takes place in presence of acid catalyst, and dilute sulfuric acid we use as the catalyst. Now let us try to talk about the mechanism of this addition there. How does this reaction takes place? Let's try to talk about the mechanism. Now in this case, first of all, in presence of acid, this water molecule, we can activate it. We can make it active. So the H plus will water molecule will grab this hydrogen ion to form what we call is the hydronium ion, H3O plus, and this can act as the strong electrophile to add across the double bond. By the way, this H plus, you can get that from sulfuric acid, which has the Lewis structure, something like this, OH and OH, and this is the proton that will transfer as the H plus. So that is how it takes place. So either we present this way or H plus, that should be fine. So in this way, we generate hydronium ion, and this can act as a strong electrophile to add across the double bond. Now let us use this double bond, again unsymmetrical alkene, because we are trying to learn about the Markovnikov rule also. We use hydronium ion with the plus. Now this double bond will grab the proton, and this plus charge will be neutralized by breaking this bond. So the result here is hydrogen will add across the double bond, and that will go by the Markovnikov rule, containing larger number of hydrogen, and we generate the carbocation, more stable carbocation again by following the Markovnikov rule, and H2O as the side product. Now water is a good nucleophile. So this water molecule that is forming as the side product, that can act as the good uh, nucleophile and will attack on the carbocation. The result here is, so again you need to follow this mechanism very well. So hydrogen here, first of all at the carbocation you are adding water molecule HOH. Now this oxygen has 3 bonds, that is why it will have the positive as a formal charge. Now the next step we can call that as the deprotonation step. You can use other water molecule or HSO4 minus, that is coming as a side product also, to grab the proton. Okay, this proton will be grabbed, and this O will the positive charge on O will be neutralized. So in this way we add hydrogen on one carbon, now we have OH on the other carbon, and you regenerate that H3O plus is regenerated. So here acid is acting only as the catalyst. So this is how we draw the mechanism for the addition of water across the double bond, and we consider that as the acid catalyzed addition of water. And not only the water, again we can extend this discussion for the alcohol also. And water and alcohol addition takes place exactly in the same way, so please try to understand that. So if say we are adding, this is the alkene, we are adding alcohol, say for example methanol. Again, the pKa of alcohol and water is almost similar, like nearly 16. Okay, very close to 16. So if you do just reaction here, so this is pKa close to 16. So if you add methanol as such, no reaction takes place. Again, the same reason, right? Not acidic enough. This hydrogen is not acidic enough, and if this hydrogen grab, then OCH3O minus is a strong base, so that cannot be the leaving group. So those are the explanation why this reaction would not occur. But again, we can talk that as the acid catalyze. We can do this reaction using acid catalyze addition of alcohol, same as addition of water. Okay, alcohol. So we use the catalyst, so CH3OH, in presence of catalyst, little bit of H plus. Again, normally we use dilute sulfuric acid as the catalyst. So how does the addition takes place? Again, it follows the Markovnikov rule, right? Hydrogen will add to the carbon with larger number of hydrogen, this hydrogen, and OCS3, that is the other part, that will go to the carbon containing less number of hydrogen, OCS3. So this will be the major product. That is how we get the addition of alcohol takes place. And again, we can explain the mechanism also exactly in the same way. Mechanism. So here, first of all, we need to activate this alcohol by acid catalyst. So this will grab the proton and this alcohol is now activated. So this can act as the strong electrophile. And this is the alkene that we use, and we have CS3O, H and H as a plus. Then double bond will grab the proton and it will be neutralized. And again, it is same as the addition of water. So hydrogen will go to the carbon with larger number of hydrogen. So plus charge is generated. Now CS3OH is the side product that can act as the nucleophile. That is when we'll attack on the carbocation. Now you have hydrogen there, and this is where you have OH and CS3. This is when you have the positive charge because oxygen has 3 bonds. And then finally deprotonation step with other molecule of methanol that will grab the proton and the plus charge will be neutralized. So the result here will be OCS3 in one carbon, hydrogen in other carbon. This is how the addition of alcohol takes place. So this is how the addition of water and alcohol occur by acid catalyzed mechanism. Now we can give some examples. For suppose we have some kind of alkene, like this alkene, we are adding, for example, ethanol. Again, we have if it is not acid catalyzed, the reaction will not take place. Now you need to determine what will be the product, major product will form. So again, hydrogen will add to one carbon and this ethoxide will add to the other carbon. Again, it will follow the Markovnikov rule. Therefore, the major product is going to be here. Double bond will go to single bond. Hydrogen will add to this carbon that containing larger number of hydrogen, and other carbon you are adding CS2, CS3, OCS2, CS3 ethoxide group is added to other carbon. So this is how we can predict the product of this reaction. And again, if we are adding, for example, other example that we can also discuss as suppose we have something like this alkene and we wanted to add water in presence of acid catalyst, right? We wanted to figure out what will be the product. Then again, the hydrogen, it will go hydrogen and OS, that is what will be added across the double bond. Hydrogen will go to the carbon with larger number of hydrogen and OH will be added to other carbon. But again, this reaction takes place only in presence of acid catalyst. Okay, so this is about the addition of water and alcohol across the double bond. All right, thank you. We'll see you in next video. Great, good.